Hi dear students, welcome to the next chapter from physics and which is called the rotational motion. This is a interesting chapter. At the same time, if you have learned in a very conceptual way, it is easy for you to understand and solve the problem. Okay, so let's start the first concept from the rotational motion, and which is called the center of mass, and what is called center of mass, and some related questions and problems. Then we'll go to different areas like moment of inertia. There are theorems which are related, like perpendicular parallel axis theorem and so on. So lot many things will be there. We have to do within a short period of time, but yeah, we will go and do the things. And rotational motion is mainly an important chapter. Why it is saying it's an important chapter in the sense because definitely you will get some question from this chapter with 100% guarantee. There are not even a year which is passed without asking a question. So you can expect some mark, some questions, and if you studying in a proper way, definitely this will be contributing to your score. Okay, so let's start with our the first topic. The chapter name is rotational motion, so you can write down the heading rotational motion. Certain textbook which is called rotational dynamics. Dynamics means nothing called motion. Okay, so static means rest, motion means it's a movement. Okay, so there is nothing special over here. Motion or movement or dynamics, all are actually one and the same. So let's start with rotational motion. Rotational motion means what? The movement of any object is called motion, right? Okay, we are studying like one dimensional motion, two dimensional motion, laws of motion, many chapters. Rotational, you know, it is a turning effect. Okay, so this chapter is completely dealing with the turning effects of the body. Okay, how the body is going to be turned on, how the body is going to be how the turning effects will give rise to various physical parameters. In a very simple sense, if a fan is rotating, okay, so we will say it is moving. Maybe we'll say we are turning the regulator to 1, 2, 3, 4, 5, etc. So we'll see like okay, its speed is increasing. We say like its speed, but in physics it is called number of revolutions per minute. So number of revolution is a important parameters in physics with respect to the rotational motion. So the concept wise it will be the same, and there is nothing special over there. Okay, so there are a lot of parameters. So we'll start with the first concept, and which is called the center of mass. So you can write out the first subheading over here, which is called center of mass, which is called the center of mass. So what is the center of mass is actually meant? We know the whole mass of the system or all mass of the body is concentrated in a single point, and this point is called the center of mass. Okay, so the whole mass of the system which is concentrated on a single point. For example, let me take a football. So if you take a football, we know it is a spherical structure, and you can if you are an expert, you can balance it on your single finger. Okay, so you have seen like famous football players which are turning in one finger the football. So the whole mass will be concentrating to that single point. And if you are taking a perfect square, you know the center of mass is exactly located at the center of the square. Okay, so if it is a kind of a uniform structure body, then the center of mass is always located at the exactly at the center, because it is a uniform structure body. But there are bodies which having the non-uniform structures. So for that also we have to find out the center of mass. So let's move to center of mass concept. So the first point will be whole mass of the system. Whole mass of the system is concentrated on a particular point, and that point is called actually the center of mass. Okay, so in physics we have to learn one concept is called a position vector. What is called a position vector? Position vector, the definition is specify, position vector is a term, specify the position of a body, the position of a body. So position of a body means, let's take an x and y axis. So it's an x axis and this is an y axis. Suppose one body which is located here. So always we'll say from the origin you have x coordinate and you have y coordinate. X coordinate is x1, y coordinate is y1. So we'll say the position coordinate at this point, the position of the object will be here r1, which is equal to ordered pair x1 comma y1. This is called ordered pair in mathematics. Okay. Suppose if you have another object, say, which is located over here, this is at a distance of x2 meter from x-axis or from the origin, and in y2 from along the y-axis. So its position coordinates are r2. R2 is called position coordinates, and which is equal to the ordered pair x2 comma y2. The ordered pair x2 comma y2. Okay. So in physics, every objects which have a position coordinate which is specifying the position of the object. So here also this object has a position coordinates of r1 and r2. So in this case, how to find the center of mass? So one object will be here, one body or one mass will be here, another mass will be here. So this, for these two particle system, where is the center of mass? If it is a completely a square, something like this one, if it is a perfect square, you will say center will be here. This is a whole mass of the system is concentrated on a body. But if it is a two particle system, you cannot say center here, center here, center here, we cannot say. So to have that, to find out the center of mass of any body, we have a general equation. Position coordinate of the center of mass is equal to, this formula is the primary key point on this topic, m1 r1 plus m2 r2 divided by m1 plus m2. This is not limited to this one, this can be extended to any masses or any positions vectors in general. So m1 r1 plus m2 r2 plus m3 r3 plus etc. that is going on, and in the denominator side m1 plus m2 plus m3 and it's going on. Okay, so depends upon the body. So in this example we have two position vectors and we have two bodies. First body having mass m1, second body having mass m2, then m1 r1 plus m2 r2 divided by m1 plus m2. Okay, this is a concept. So this is actually the formula to find out r is called position vector of the center of mass of a two body system. This case it's a two body system. If you have many bodies, the numerator will extend, denominator will extend proportionally. Okay, so let's do one problem, a couple of questions we'll do and then we'll see. Okay, great. Okay, so you can write down one questions over there. Find the center of mass. Find the center of mass of the system shown in the figure. So we have an equilateral triangles are given and three masses are placed, m here, m here and m here. The position coordinates are 0, 0, a, 0. This is only which is given, and angles are equal, or I can say all the sides are equal. This side equal to this side, having side length a. Only these parameters which are given, and we need to find out, only this is given when we need to find out where is the center of mass of the system is located. So as I told before, we have the position coordinates. Position coordinates of RCOM. So we know this RCOM is called the position coordinates m1 r1 plus m2 r2 plus m3 r3 whole divided by m1 plus m2 plus m3. But r1 is the position coordinate of the first body, r2 second body, r3 third body. You can take in any order but irrespective of this one. But before I am going this one, So this will contain R1 is equal to x1 y1, R2 x2 y2, R3 x3 y3. So this can be written as a 3 format. 3 format means XCOM is equal to M1 x1 plus M2 x2 plus M3 x3 whole divided by M1 plus M2 plus M3, x coordinate in a formula, because RCOM containing x coordinate, y coordinate for a 2-dimensional body. If it is a 3-dimensional body like a cube, then XCOM will be there, YCOM will be there, ZCOM is also there. So then YCOM, Y center of mass, because it's a 2-dimensional body. Why I am saying like a 2-dimensional? Because 2 coordinates are given, 0, 0, a, 0, and here it is not given. We need to find that out. So M1 y1 plus M2 y2 plus M3 y3 whole divided by M1 plus M2 plus M3. Okay, question is only this much, but we know the x1 coordinates, and I am assuming this is equal to my x1 coordinate, and this is equal to x2 coordinate, but x3 coordinate I want to say. x3 coordinate means it is a x distance followed by the y distance. X distance means half of this one, this is a by 2, and y distance is this one, this I have to calculate. I know this side is a, this side is a by 2, so we can apply the Pythagoras theorem. Hypotenuse square is equal to height square. Let me take it as height. So hypotenuse square, this a square is equal to base square plus a square by 4 plus height square, h square. So h square will be equal to a square minus a square by 4, which is equal to 3a square by 4. The h square, and we need h. So h is equal to root 3a by 2. Root and side, so we got root 3. So we have now x3, whatever I have written in the red color is not given in the question. Okay, it is we are finding out. So x3 in the h coordinate a by 2, y coordinate is root 3a by 2. Now we'll substitute in this all this formula. Let me consider this as m1, this as m2. So I am considering this as m1 and this as m2 and this as m3. You can take in any order. Now we'll substitute over this formula. What is m1? m1 is m into x1 is 0, m2 is m, x1 is a, m3 is this one, m into x coordinate is a by 2 divided by 3m. So we know ma plus ma by 2, 3a by 2, 3ma by 2. So 3ma by 2 divided by 3m. So 3m cancel, and we got x coordinate is a by 2. X coordinate is a by 2. The same way will continue for the y coordinate as well. So m1 into y1. So m1 into 0 plus m2 is this body. That is the y coordinate. So m2 into 0 plus m3, the third body, m into, that is the y coordinate, root 3a by 2 whole divided by 3m. Okay. So only this got cancelled, this also got cancels, and we got root 3a by 2 into 3. So 3 can be again further simplified. So a divided by 2. This is root 3 into root 3. 3 namakku root 3 into root 3. So we root 3 cancel out. Balance another 2 root 3. So a 2 root 3. So here the position coordinate. So the answer to this question will be RCOM is equal to position coordinate a by 2 comma a by 2 root 3 is the final answer to this question. So this is the coordinate, which means the center of mass is located a by 2 distance from x axis and a by 2 root 3 distance from y axis. So it may come somewhere over here. Exactly, depends upon if you are plotting the graph over will be here, we will get the answer. But this is a position coordinate of the system. Here I have taken as an example of an equilateral triangle. The same question may ask in case they will give you a square. So you have 4 masses will be here. Okay. So in case of a triangle, we have only 3 masses. So 3 terms, both numerator and denominator. But in case of a square, we have totally 4 terms in numerator and denominators will come. So depends upon the question. Okay, that's all. and we'll going to learn with the center of mass concept for a two particle system. This is more than like a two particle, right? This is not limited to a two particle system. This is more than a two particle system example. So fine. Clear? Hope this is clear to you. Fine. Then write the next heading. Center of mass of two particle system. The next heading, center of mass of two particle system. You can write in short as COM, center of mass of two particle system. Two particle system. Center of mass of two particle system. Listen to the board very carefully. Suppose I have the first mass m1, I have the second mass m2. And from here the coordinates are 0, 0 and the coordinates are 0, r, which means the second body is at a distance of r. So I don't know where is the center of mass. I am assuming the center of mass will be here, and which is at a distance of r1 from the first body. Anyway, if you see the y coordinates, this is r, 0, right? Okay, y coordinates are 0. So y coordinates are 0 means y center of mass is also 0. X coordinate is changing from 0 to r. So only x coordinates will change us. So now we know this is center of mass point, and the distance from these 2 points are r1 and r2 respectively. In this case, we will apply the formula to find out the center of mass for the first body. So let's take RCOM, which means we have XCOM and YCOM because it's a two body. But if you look into the y term on both sides, y is not changing. From this itself we can say YCOM equal to 0 because y parameter is not changing. X parameter is only changing. So we can find XCOM, x coordinate, the distance of x coordinates from here. What is this one? M1 into x1. x1 is 0. M2 into x2. x2 is what? R divided by M1 plus M2. X center of mass is the value of the position coordinates from the origin. 0, 0 is the origin. So XCOM is actually what is called R1. That is the distance from the first body to the center of mass point. This is a center of mass point. So that distance is called R1. So I can say R1 equal to M2R divided by M1 plus M2. This is important. I'll tell you why this is important. Next, if I want to find out R2, R2 means what? R minus R1 because the total distance is R. The total distance is given as R. Okay, we'll subtract R minus M2R divided by M1 plus M2. So what will get? M1R divided by M1 plus M2. This is called R2. Okay. Now the trick is going to start over here. Listen very carefully. R1, listen very carefully to the board. R1 is the distance of the center of mass from the first body. R1 is the distance of the center of mass from the first body is equal to second body into distance between the two bodies divided by total mass. Other way around, the center of mass point from the second body, that is R2 is equal to first body into distance between these two bodies divided by sum of the masses. This is clear, right? First body in the distance ആണ് R1. അപ്പോൾ അതിൻ്റെ center of mass is second body into the distance between the two body divided by M1 plus M2. അപ്പോൾ first body in the distance, if you want to find, numerator is the second body into distance between them. If you want to find out the distance from the second body, the numerator is the first body into distance between them divided by sum of the masses. Keep it in mind. Okay, Then another parameter I am writing m1r1 equal to m2r2. This is a valid relation or not? Yes, it's 100% valid. Why? m1 into r1. If you multiply m1 into r1, what is r1? m2r2 divided by. So what you will get? m1 into. You know what is r1? m2r divided by m1 plus m2. And you know what is r2? m2 into. What is r2? m1r divided by m1 plus m2. This already you know. Now you can see both are equal, right? So this relation we will use, and this is 100% true case. This is a 100% true case. So which means depends on the question. You may have to use this one, you may have to use this one, you may have to use this one. Okay, but remember it's applicable for a two particle system. Okay, we'll do some questions over here so that it will be very clear to you as well. Okay, fine. Let me clean the board and then we'll start to do the questions. Center of mass, so just keep it there. Center of mass of a two particle system. So two particle system examples. Okay, we'll do couple of examples, then it will be very clear to you. We'll do a couple of questions, and yeah, these are the real neat questions only, not the one I have derived from somewhere. Okay, listen to the board very carefully. We will do some questions. We have a T-shaped structures given in the question, a T-shaped structures. So the length of this one is L, and here its length is L. Both will have a mass of m and m respectively, and this is just standing over here on the ground. Question is, find the center of mass of this system from the ground. Find the center of mass of the system from the ground. Ground in the center of mass, how much height? For this question, what you want to do means, you have to consider for all this type of model, what you have to do means, you have to do a transition. What is the transition is talking about? You want to make it as a two particle system. First you consider this is one particle and this is two particle. For this particle I am drawing will be here as a small square piece. So this particle is in a mass m, but ground will be here. From the ground, within the center of mass point, ground will L by 2 height. So this distance is from the ground is L by 2. Keep here. So extra how much will be here? L by 2. We consider like a just like a particle, L by 2. Then this first particle. In second particle, second body in a second particle to consider. So second body will be here. And its distance from the left side, this is the correct center. Okay. Now, this is bottommost point. How much height the center of mass will be located. So this is the first body. We know this point will be here. The first body point will be here. Second body point will be here. So left a distance under L by 2. Right a distance under L by 2. Now this is like a two particle system. Now for me, again, this is just for your understandability I have drawn. I will do again one more transition, and this transition is talking to me only. Hey, I just consider one dot, I just consider another dot. First dot is m, second dot is also m. This is now converted into a dot. What's the distance between these two particles now? L by 2. Now we are going to find out R1 and R2. Suppose I am assuming center of mass will be here. So this is at a distance of R1 meter away. So what is the balance distance? Balance distance is R2. You don't find to find both, because the total distance is how much? L by 2. I am finding R1. R1 from where? R1 from the first body. First body means this is I am considering like M1. This is I am considering like M2. Both are equal. So distance from the first body is equal to what? Is equal to the second body into the distance between the two bodies. So M1 is a first body, so its distance from the first body is R1. So the second body M into distance between the two bodies. So second body, so we will first write the formula M2 into R divided by M1 plus M2. What is M2? M2 is M into distance between them L by 2 divided by M1 plus M2. It is 2M. So answer is how much? M get cancelled, L by 4. L by 4 is the right answer? No, wrong answer. No, L by 4 is not the wrong answer. This case, but what is the question? Your distance from the ground. Okay, so now we have the first body and we have the second body. Now it's look like now the center of mass from the first body is located how much distance away? L by 4. But from the ground, how much distance is already we have? L by 2. So the center of mass point, center of mass from the ground, center of mass from the ground is equal to L by 2 plus L by 4. L by 2 plus L by 4. So how much will come? 4L plus 2L. Okay, so this is 0.5, 0.25. So 3 by 4L, 3 by 4, 0.75L will come. So 3 by 4L distance from the ground. So the center of mass will be located at will be here. 3 by 4L distance away. This is actually the center of mass point of this rod structure. It is given as a rod, but we considered as a two particle system. That is the importance of studying two particle system. Any big system, if you see some similarity of the system, you can able to make it as a two particle system. That is the beauty of this one. Okay, hope this is clear to you. So let's do one more question from this topic, so that will be very clear to you as well. Okay, so let's start. So hope this question is clear. Any big objects, any big structures are given to you in examination paper. Think, is it possible for you to convert into a two particle system? Okay, so let's do. Some cases they will give you in terms of density. Okay, now it is given as mass. Okay, so just make a note. In some case instead of mass rho is given. Rho will be given. Rho means density. So how you will do mass equal to rho into V. We have to substitute accordingly. That's all. So we'll go to the next question. Okay, now we have a cube structure. Okay, so we need to find the center of mass of the system. Okay, now this is actually located in this x axis, and this is the y axis, and this is the z axis. So for mass are located on over here, back side il 4 mass. And mass M, and this is M. In the front side, a cube in the front side 1, 2, 3 and 4. This mass 2M, this mass 2M, this mass 2M, this mass 2M. So this many masses will be given. So you have to find out the center of mass of the system. So all having the equal distance A. So everywhere the distance will be the same. So what you want to do? Now you know this is a cube consists of how many masses will be there? Totally 8 mass. 8 mass will be there. So what you can do? You know this is the origin. അപ്പോൾ ഇതിൻ്റെ പൊസിഷൻ കോർഡിനേറ്റ് ഇപ്പോൾ നമ്മൾ ഫസ്റ്റ് എടുത്തന R1 means x1 y1 z1 because it's a 3-dimensional structure. x1 is 0, y1 is 0, z1 is 0. ഇതിപ്പം R1. Okay, so for this body let me take it as R1. In the second body ഇതെടുത്തന ഇത് R2. So R2 equal to, what is the position coordinates of this one? It is on the x-axis. So A comma y is 0, z is 0. Okay, R2. So R1, R2, maybe let me take it as next red. Next red means I will take this as R3, for example. So R3 will be equal to x0, y a, and z is also 0. So if you do like this one, you have to do till R8. Okay, then you have to do m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus m5 x5 plus m6 x6 m7 x7 m8 x8. Okay, examination will be over if you do like that. Okay, 3-hour NEET examination or 3-hour JEE examination, whatever you are writing, that will be over. And finally, at the end of the time, there is no guarantee what you are getting is correct or not. Here the tricks comes. You can do like this one, but it is possible, but it is a tedious job and it will take a lot of your time. So in order to do, in order to solve this one, this body is also considered as a two-particle system. What is a two-particle system? Okay, what I am going to do means the total body is considered as a two-particle system. Two-particle system means, listen very carefully, the back one m. So e 4m. Okay, 1m. So this is considered like a two masses. I mean, not two masses means it's a single masses. For example, listen to the board very clearly. 1m, m. So this is m, this is m, this is m, this is m. Okay, we are making the 3D structure into a 2D structure. So these 4 masses are, these 4 masses in the center of mass will be coming here. Back side on. This is the red color in the back side. Okay, now the x coordinate a by 2, y coordinate is also how much will come? A by 2. So the x coordinate a by 2, y coordinate a by 2, z coordinate 0, because in the xy plane in the back side. You have to imagine this red is the back side. Back side is z front z. So back side is x and y axis. So x a by 2, y axis a by 2, z axis 0. In front we have another body, this blue color one in the front side. So blue color one in the front side. Okay, so in front we have a blue color. This is 2m, 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 2m. Okay, 2m, 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 2m. So this you can consider as one position coordinate. Let me consider as R1, and the total mass of this system is concentrated at this point, that is called 4m. Here the total mass is concentrated at this point and it is called 8m. What is the position coordinate? Now you have to assume you are coming forward. You are coming forward means the center of mass will be located very clearly. It is on this space, because now we have this. Now we have the front blue color shaded area. Now we have the front blue color. So the center of mass will be located, and we have to travel some distance into front side. How much we have to travel? A by 2 we have to travel front, and we have to travel y, because it is some height. So y a by 2, z a by 2, x also a by 2. So we have a by 2. So back side 4 masses m, all together it is called 4m, and which is located a by 2, 0. In this front blue color, we have to come to front side fully. This front side fully. So z coordinate is a, x coordinate in half, y coordinate in another, x coordinate in half, y in half. Then we have to come to front side full light, because this is at the front side, other one is back side. X a by 2, y a by 2, z is a. Z is not a by 2, z is a, because we have to come fully into the front. Other one is back side. Back side is origin position plane, that's what it is, 0. Now we have a two particle system of mass 4m and 8m, and we have x coordinates, y coordinates. Now if you look over, will be here. The beautiful things over will be here. Your x coordinates are changing? No. So XCOM is equal to a by 2. Your y coordinates are changing? No. So your YCOM is equal to a by 2. Your z coordinates are changing? Yes, from a to 0. So what you can do means, Next transition, you consider like one mass, you consider like the next mass, distance between the two mass is equal to a, and the first body is, the upper body is 4m, next body is 8m. Okay, so we are finding the distance from the origin is 4m, so I am considering this as m1 and this as m2. Distance to the center of mass is r1. How to find out r1? You know, r1 is equal to second body 8m into distance between the two bodies, a divided by sum of the masses, 4m plus 8m. Answer is 12m. m cancels. This is for means 2 by 3, so it is 2a by 3 will come. So 2a by 3 from the origin. So from the origin a by 2. All these are from the origin. A by 2. 0 start from the origin. That's what we are finding. R1 from top. So ZCOM is equal to 2a by 3. So if you are very thorough with the concept, we can easily find the solution for these questions without wasting much time. Okay, so else we have to normally go with our traditional method, r1 x1 y1 z1, r2 x2 y2 z2, r3 x3 y3 z3, instead of doing the problem in such a way that we can also do the problem by considering this like a two masses system. And let me tell you one more thing, and the masses over will be here are equal. That's what the complete masses comes as 8m on the front side and 4m on the back side. If the masses are different, of course you cannot apply this method, but there is a very less chance, less than 1% chance as given the masses has different value. It's very rare case. So far I didn't see any paper like the masses are given as a different value. Masses they will give you like this, either it's a 2m and backside m or any other values, but all are same format like this one. If such cases are coming to you, you have to consider like a 2 particle system, not like a 8 particle system. Actually we have a 8 masses will be here, so we may initially think like it's a 8 particle. No, even though we have 8 particle, there is some uniformity there. Because of the uniformity, we consider this as a 2 particle system, and coordinates of x are not changing, coordinates of y are not changing, but only the coordinates of z is changing from 0 to a. For ZCOM we have calculated using this method. Okay, question is bit tricky, and question is tricky, answer can be do it in a tricky way, and within 1 or 2 minutes you can finish the answers and you can go with the next question. Hope the concept is clear to you, what we have discussed today, and we'll move to the next question, like the couple of other formulas, couple of other theoretical stuffs over in with respect to the center of mass. Okay. Okay, so good. Let's do that part and we'll move to the next area. Okay, so the which means basically the topics which are connected with the center of mass is now we have learned about the position coordinate. Position coordinate is nothing but a simply called distance. We know from the distance we can derive differentiation of the distance is equal to what, or displacement is equal to what, velocity dx by dt. So here dr by dt will come. So dr by dt is nothing but velocity. Again we are differentiating the velocity, will get acceleration. So center of mass is related with velocity, acceleration in addition to position vector. That is a next topics we are going to see now. Welcome to the next topic. Okay, this topic is as we told in the last topic itself, we have a derivative of center of mass will be there. Derivative of center of mass means we will see very detailed about it. Look into this board. Okay, so you can write down the heading called motion of center of mass. Okay, We know the center of mass formula. We have an x coordinates, we have y coordinate, we have an z coordinates. So we have RCOM. In general, the position coordinates are for two bodies M1 R1 plus M2 R2 divided by M1 plus M2. This already we know. If you are differentiating both sides, the difference of the center of mass point is equal to M1 into difference of the first M d2 R2, difference of the second, divided by M1 plus M2. This is one concept. I will tell you what it is. This indicate in numerical problem, this is very much required. This indicate change in the position of center of mass. Change in the position of center of mass. If center of mass is not changing, then what is the value of the difference? If it is not changing, means final position is equal to initial position. So drCOM is equal to 0. If it is changing, then it should have a value. dr1 is the change in the position of the first body. So let's say change in position of first body. Okay. So what about dr2? Similarly, change in position of the second body. Okay, and we have the sum of the masses. This is one equation. This is like we are taking the difference of the distance. Now, if I am dividing the distance, then what should I will get? For example, drCOM divided by dt is equal to m1 into dr1 by dt plus m2 into dr1 by dt. I am taking the rate of change of position. Rate of change of position. This is only change of position. So this equation is all about change of position. Change of position. Change of position. This equation is all about rate of change of position. Rate of change of position. Rate of change of position. Rate of change means what? Physics, rate means divide by time. Divided with plus m1 plus m2 divided by the sum of the masses. So what is this drCOM in practical? This is equal to velocity of the center of mass m1. This is called v1 plus m2 v2 whole divided by m1 plus m2. This is the velocity of the center of mass formula. So we have a position formula, position change formula, we have a velocity formula. Now I will do one more thing. If I am differentiating velocity, what should I will get? I know dvCOM divided by dt is equal to m1 dv1 by dt plus m2 dv2 by dt whole divided by m1 plus m2. So what is the final formula for this will come? This is acceleration of the center of mass equal to m1a1 plus m2a2 divided by m1 plus m2. This is the acceleration of the center of mass point. Okay, so I have given you a couple of formulas. One is change in the position. This is the velocity. Rate of change of positions will give rise to velocity formula and acceleration formula. Simple ആണ് m1 r1 plus m2 r2 divided by m1 plus m2 ആണ് position formula. Velocity വരുമ്പോൾ m1 v1 plus m2 v2 by m1 plus m2. Acceleration ആണ് m1 a1 plus m2 a2 divided by m1 plus m2. It's very simple, nothing, no more complications. But yeah, we'll see. We have few more points has to be added into the theoretical area. Okay. So what is this theoretical area which indicate force on the mass system? So I will explain to you. Let's see. Okay. So the points which we are going to discuss will be here. You can write a note. We are discussing about some key points. First one, if total force or total force, this total force can also be said that the net force. So F net is equal to 0 if we are not applying any force on the system. if you're not applying any force. If total force on the system is equal to 0, acceleration of the center of mass equal to 0. Acceleration 0. Acceleration 0 means, this means that what? Rate of change of acceleration is called, rate of change of velocity is called acceleration. Acceleration means velocity is not changing, constant speed, ore speed aambo the acceleration 0 aayirikkum, velocity constant aayirikkum, velocity constant. In another way we can say, next point, if system is at rest, system itself not moving, the whole system is not moving, then I can say F net equal to 0, A COM equal to 0 and V COM, system, the body itself not moving. First case we are not applying any forces, but a system which is moving with constant speed and acceleration is equal to 0. But what about the second case? In the second case, total force on the system is equal to 0. System is initially at rest position. And what else? Rest position means no acceleration, no speed change, it is not at all moving. So this is the thing. So if F net equal to 0, ACOM equal to 0, which means VCOM is equal to 0. Two derivative, F net equal to 0, ACOM equal to 0, VCOM is a constant. Constant means it can be any value. If I am saying like 0, 0 is a constant number. It's an integer number, right? So it's a constant. Or in another way, I can say 1 meter per second, 2 meter per second, 3 meter per second, anything. But it is constant throughout the system. That value is not changing. Okay. This is just a kind of a key point which we will use while we are solving the problems. Okay. This is a key point, and yeah, we will do some questions out of this one. Okay, fine. If we have, let's have a question. If we have two bodies, 2 kilogram and 6 kilogram, രണ്ട് body ഉണ്ട്, we have a 2 kilogram and a 6 kilogram. Okay, the diagram is showing will be here, the 2 kilogram and the 6 kilogram. So two bodies over will be here. If the 6 kilogram moves 2 meter towards right, then how much 2 kilogram should shift so that center of mass location not changing. Center of mass location changing. But under body under we have 2 kilogram and 6 kilogram. It's saying like the 6 kilogram body moves a distance of 2 meter towards right side. Then it is saying like that the center of mass is not changing. So which means this body will have initially a center of mass point is located. The body will have initially a center of mass. So this was a question. I am assuming the distance between the body is equal to r and it's not given. So the question will be given, this body is shifting, moving towards 2 meter towards right side. Right side means for us it is positive x-axis, right? This is our plus x, this is our plus y, this is our minus y, and this is our minus. So plus x distance body is moving 2 meter. So here position is changing. So we have to understand which formula I have to use. So now we have totally how many formulas for center of mass? 4 formulas. Totally we have 4 formulas for center of mass. M1 R1 plus M2 R2 divided by M1 plus M2. First formula. Adine X undu, Y undu. X COM, Y COM, Z COM. Second formula, DRCOM is equal to M1 dr1 plus M2 dr2 divided by M1 plus M2. Third formula, M1 V1 plus M2 V2 plus M3 V3 divided by M1 plus M2 plus M3, depends upon the body. Third, the final fourth formula is with respect to the accelerations, M1 A1 plus M2 A2 plus M3 A3 divided by M1 plus M2 plus M3 for a 3 body system. So here which one I have to use? I have to use velocity formula, have to use the first formula, center of mass formula? No, I have to use the rate of change of position formula. No, rate of change of position means what? Velocity. Question is not asking about velocity, question is asking about what? Rate. No rate, change of position. The position is changing. Position of which board is changing? 6 kilogram board is changing. So let's have the final question. Let's have the answers. dr/CROM equal to m1 dr1 plus m2 dr2 divided by m1 plus m2. So this is the change in the position of the center of mass. Question is saying like, how much should I have to shift a 2 kilogram mass on the center of mass location is not changing. So no change means this is 0, is equal to m1 is the first body. I am assuming this is m1 and this is m2. So m1 is the first body. Whatever given will be there as a question. Now we'll come to the answer part. So dr1 is the shift of this one. So m1 is how much? 2 kilogram into dr1, this is not given, plus m2 the mass is 6 kilogram. Right kana poyirundana plus, if it is moving left minus, if it is moving down minus, if it is moving up plus. Now this 2 meter is right side means plus 2 divided by total mass of the system 6 plus 2 8. So we'll simplify this one. So how much we'll get? 2 times of dr1 is equal to 6 into 2 12 minus 12 and dr1 equal to minus 6 meter. What does this minus indicate? Minus indicate 2 kilogram is moving right or left. 2 kilogram, it's not moving right side, 2 kilograms are moving left side with for a distance of 6 meter, so that the center of mass location is not changing, it is fixed. That's the meaning. Minus vandana minus x axis ilana adinte movement, because 2 is 6 kilogram, right ku 2 edukumbodhu the 2 kilogram has to move 6 meter towards left in order to keep the center of mass point at the original location. Okay, so this is important. We have to apply the concept accordingly and has to find the answer for this one. Okay, so let's move to the next one. Let's do one question, the next question. Okay. Find the velocity of the center of mass of the system shown in figure. You have two bodies, first body and second body. First body moving with a velocity 5 meter per second, making an angle of 37 degree. Second body moving with a velocity of 10 meter per second, making an angle of 37 degree. Please make a note of this question. So we need to find out the velocity of the center of mass of the system. Two bodies which are moving 5 centimeter, both will have a masses of, this is 1 kilogram and this is also 1 kilogram. We need to find out the center of mass of the system, which is shown in the figure. Whenever you see 37 degree, immediately you simply draw a triangle like this one. This is very important because cos 37, sin 37 value sometimes may be given in the paper, sometimes may not be given. So this is 3 and 4, 5. Do not confuse, opposite side is always 3. Okay, so what we are going to do? So in order to answer this question, what we are going to do here, this motion is a two-dimensional motion. So we'll split this into x component of velocity and y component. What is x component? 5 cos 37. 5 cos 30. Cos 37 means what? Adjacent side by hypotenuse. So 5 into 4 by 5. Cos 37 means 4 by 5. cancel ayina x direction 4 meter per second. In y direction 5 sin 37. So 5 sin 37 means what? 3 by 5. So this is equal to 3 meter per second. Appo first body x coordinate, first body y coordinate. So x first body let me write as x1 comma y1 is equal to, x1 is what? 4 right side aanu mele pogumbodhu positive, so 4 comma 3. So this is clear. And for the second body I am writing, I have an x coordinates of 10 cos 37. So 10 into cos 37 means what? It is a two-dimensional motion, right? So we are splitting to horizontal and vertical component. Cos 37 means what? 4 divided by 5 adjacent by hypotenuse. So 2 into 4, which means 8. And we have a downside one. Downside 1 means what? Downside 1 is 10 sin 37. You have to put a negative here because it's going downward. Okay. So 10 into 3 by 5 negative and 2 minus 6. So here the ordered pair x2 comma y2, and which is equal to 8 comma minus 6. So we have two things. Now we have x1 y1, we have x2 y2, formulas will be here. This is not actually I can say this is velocity in the x direction, velocity in the v x1 v y1. I can say v x2 and v y2, I can say. Okay, so let's consider this two body will have a two system, and we have to find out velocity in the x direction for the center of mass. Velocity in the x direction for the center of mass. m1 v1x plus m2 v2x or vx2, both are same, divided by m1 plus m2. What is? So two body m1 first രണ്ട് body 1 kilogram ആണ്. 1 into first ന്റെ x വരും how much? 4. second body mass 1, അതിന്റെ x എന്ന് പറയുന്നത് 8. It is 8 divided by the sum of the two masses. How much it is? 2 kilogram. So here 8 is positive and 6 is also, and 4 is also positive. So substitution is correct. 12 by 2. 12 by 2 means 6. So x direction 6 ആണ് velocity. Similar way we have to find the velocity in the y direction. So vycom is equal to m1. m1 means 1 into v1 into y, v1 into y 3. m1 v1 plus m2 v2, അത് x ൽ എടുത്തു, next y ൽ, plus 1 into minus 6 divided by 2. So how much will come? 1 into 3, 3 minus 6 minus 3 by 2. So minus 3 by 2. So we got two velocities. One velocity is in the x direction and another velocity is in the y directions, right? And these two velocity we have to use to solve the one. So we have x component of velocity and we have y component of velocity. Now it's look like this one. This is x component of center of mass, and this is the y component of center of mass. X component of center of mass is what? 6. Y component is means minus 3 by 2. Minus 3 by 2. So minus 3 by 2. Now the resultant velocity VCOM. This is x and this is y. Okay. How to find out VCM? Two vector, random perpendicular. X square plus y square. So Vx square, VXCOM square plus VYCOM square. So which is equal to root of 6 square. 6 square plus minus 3 by 2 the whole square. You can solve so that you will get the answer. Okay, rest you can solve, right? 6 square 36 and 9 by 4 you can solve it. So this is the concept behind this one. So here we have used the velocity formula because question is asking what is the velocity of center of mass. Here we have it's a two-dimensional motion. So x component of velocity and y component of velocity. This vector na resolve we are resolved. Here also we have resolved. Okay, so the component which is nearer to theta is called cos theta and another one is called sin theta. This side theta. Okay, so this angle is called theta, means theta ku pakkathil irukkunna side. So it's very close to theta, very near to theta. Theta ന്റെ അടുത്ത് ഇരിക്കുന്നത് വളരെ ക്ലോസ് ആയിട്ട് ഇരിക്കുന്ന ഏരിയാസിൽ വരുന്നതാണ് cos. Other side of course it is sin. Okay, so you know this already from other lessons as well, so I just repeated. So okay, so now you have find the x component here and y component here. Now you have x1 y1 vx1 vy1 vx2 vy2 or v1x v2x, both are same, and we substituted in this the velocity equations over here, and we calculated the value of the same thing. Okay, fine, good. Great. So let's move to the next question on this one. Okay, so with respect to position change we have done one question, with respect to velocity change we have done one question. Now we will do one questions with respect to the acceleration change. Okay, so this is similar to the one you have learned from me in laws of motion. Okay, in laws of motions I told you some tricks and tips, right? To find some tricks and tips I've told you to find out how to find out the acceleration in case of a pulley system. Okay, so the same logic whatever you have learned in your first year topic, the same things we have going to apply here also. So question is, find the center of, find the ACOM, acceleration center of mass of the system shown in figure, So it's a pulley system, whatever we have learned in laws of motion, 1 kilogram, and this is 2 kilogram. Okay, so we have to find out this is a system over which the center of mass of the accelerated system. So acceleration ACOM is equal to m1a1 plus m2a2 divided by m1 plus m2. This is what we know. But what is a1 and a2? A1 is the acceleration of this body will go upward, a1, this will go, body will go downward, but we know a1 is equal to a2 because it is a single pulley. 2 kilogram so 1 kilogram will going upward. So I know A1 is equal to A2 is equal to A. Let me put it as A. A is equal to, what is the shortcut I taught you in that? Forward force minus reverse force divided by sum of the masses. This is what we have learned laws of motion as a shortcut, right? Exactly the same thing we are applying here. Forward force means what? This one, mg means 2g minus reverse force, idana reverse force, 1g divided by sum of the masses, 3. So answer is g by 3 is the acceleration A1 and A2. So this body will move with the g by 3 acceleration upward, and this body will move the accelerations downward. It is actually magnitude wise, I can say magnitude wise accelerations are same. But here the speciality over here, you know, A1 is moving upward and A2 is moving downward. So due to this one, our formula changes over here. A1 minus m2a2 divided by m1 plus m2. Why a2 negative? Because it's going in the minus y direction. Okay, now we are solving over here. Now we got this g by 3 part. Now we are substituting over there the values whatever we have gained. What is m1? 1 into g by 3 minus 2g by 3 divided by m1 plus m2, 3. So 1 minus 2 means what? The balance will be here. 1 minus 2 means minus 1 minus g by 3 by 3. So this is equal to how much? Minus g by 9. So which means ACOM, acceleration of the whole system, the center of mass of the system, acceleration of the system. അല്ലെങ്കിൽ ഈ ഒരു സിസ്റ്റം മൂവ് ആകുമ്പോൾ ഈ സിസ്റ്റത്തിൻ്റെ ആക്സിലറേഷൻ, സെൻറ്റർ ഓഫ് മാസ് ആക്സിലറേഷൻ ഈസ് g by 9 downward. downward. To say this is not fixed. Okay, this is not fixed. The system can be a movable. If fixed meaning. So this is not fixed. The system is not fixed. Systems can move downward with an acceleration of g/9 downward. Okay. Hope this is clear to you as well. Okay. So we'll do some questions which is related to some boat kind of problems. We have it already, and let's solve that, and we'll go to the next area and the next topic. So great. You can write the next heading as boat problem. Boat problem. Do not confuse the one in which you have learned the boat problem, rain man problem, river problem, all the things you have learned in two-dimensional motion, right? So do not confuse with that, and there is no confusion at all, but this is entirely different. So you can say boat problem in center of mass. Boat problem in center of mass. So let's directly start with a question, then we will see how the things are coming. Okay. The question is, based on the question we will discuss, what will be the displacement of the boat when Manoj comes from one side of the boat to another side. So we have a diagram which is given. This is a boat system, and the length of the boat is equal to 4 meters, and a guy who is standing here, and when he is moving towards the other side, so he is not fixed to one side, and he is moving towards the other side. Okay, so let me make it. Okay, so 4 meters, and the weight of the boat is equal to 40 kilogram. This is just some values, right? Okay, so I placed my own values. You may think like that, okay, 60 kilogram will be there on 40 kilograms, so it will float down. No, nothing. So let's make it as 30 kilogram, then it's simple. Okay, so a 30 kilogram man will be there, and what will be the displacement of the boat when Manoj comes from one side of the boat to another side? The system is at rest initially. The system is at rest. There is no external force. Okay, there is no external force, and center of mass remains at the initial position. Okay, there are no external force. So remember one thing, the system is rested initially means F net, no force acting on the system, acceleration due to center of mass equal to 0, velocity at the center of mass equal to 0. If velocity is 0 means position is not changing, I can say drcom is fixed means I can say not changing, is fixed, or I can say it's not changing. If drocm is fixed or not changing means I can say that is equal to 0 m1 dr1 plus m2 dr2 divided by m1 plus m2. Okay, question is, what will be the displacement of the boat? How much the boat will move when the Manoj is trying to move from one side? System initially at rest. From that one we have this conclusions. So what will happen if a person is walking? If a boat into a common once you are moving forward, you are actually pulling your leg backward in order you have to move forward. So you are pulling your leg backward. If you are pulling your leg backward means what will happen? Boat will have a tendency to go in this direction because you are pulling the boat backward and you want to go forward. So what will happen? Suppose I am assuming the boat is shifted by a distance of x meter towards left because he is moving right side. So listen here, this is equal to 0. So I know. So which means M1 means the first man 30 kilogram and he is shifted. He is trying to travel 4 meter along x meter in the backward shift. So 4 minus x. Okay, he is moving 4 meter. So there is a x meter shift in the backward direction. So both are opposite, 4 minus x. Plus the second body is the boat 40. Boat is moving only in opposite direction, minus x. Divided by m1 plus m2. m1 plus m2 means 30 plus 40, 70 equal to 0. You have to solve this one and find the value of x. This is what we are going to do. So let's solve it. 30 into 4, 120 minus 30x minus 40x equal to 0. So x will be equal to 120 divided by 70, which means 12 divided by 7 meters the boat has to shift. This 1 point something, 1.6 or 7. So this much values the boat will be shifting. So what we understood, a man is walking on the boat and the boat is moving in the backward direction. But any shift in the center of mass position? No. The point will be here, center of mass will be, the system is initially at rest. So system is initially rest means we'll come to this two conclusion. There is no external force, only internal forces will be here. And additionally, it's given system is at rest. There is no force, nothing will be there. Okay. There is no force means there is no external force, only the internal forces will be here. So internal force means you are moving backward, you are pulling another body in backward, then only you can move forward. Okay, that is a basic principle of a boat also, right? We are pulling it backward, so boat will be moving in the forward direction. The same concept will be here also. So how much you are moving upward, accordingly there is a shift in the boat. And what is that shift? That is actually the question over here. Okay, next one, the same man boat problem, but can ask like in another way. Let's keep this question here. This is similar to the same, more or less similar question, but the point over here, what will be the displacement of the boat when Manoj and Raju comes from one side of the boat to another side? This is Manoj and here Raju, and this is Raju. So Manoj and Raju, now we have two persons who are traveling. What will be the displacement of the boat when Manoj and Raju comes from one side of the boat to the middle? So this guy is traveling 2 meter and this guy is also traveling 2 meter. Both are coming and locating at the center. So it's like a 3-particle system. System is initially at rest, so there is no change in position. So 0 equal to m1 dr1 plus m2 dr2 plus same method m3 dr3 whole divided by sum of the mass sigma m. So m1 means first body 30 kilogram. Adina distance how much he has to travel? He is only traveling 2 meter, not the full end. He is not traveling, only half. Question I just change it little bit. So 2 minus x, 2 meter right to go, boat left to go, 2 meter x. Ini adutha case, boat into the 40, boat is moving left, minus x. Third body, Raju in the weight is not given, I'll put it as 20 kilogram. So Raju is 20 kilogram. Okay, so Raju is 20 kilogram. So 20 kilogram body. Here Raju is moving minus 2 in this direction, 2 in this direction, and x is also in this direction. So both are in the minus x direction. So minus 2 minus x whole divided by mass of everything, 30 plus 20, 50, 50 plus 40, 90. So this is equal to 0. The sign convention understood. Here 2 right side x, backward, അതാണ് 2 minus x. 40 കേസിൽ ബോട്ട് നെഗറ്റീവ് എക്സ് ഡിറക്ഷൻ, സോ മൈനസ് എക്സ്. ഈ 20 കേസിൽ -2 and -x, both are in this directions. Okay, understood? The question will be clear? Question will be clear to you? Okay, perfectly. So here x, remember one thing, you may have doubt, sir, here he is walking in this direction and you consider x in opposite direction. Then in that cases, if Raju is walking in this direction, then x should be in this direction, right? Might be possible. It is possible. Okay, here I am assuming 2 meter, Manoj is moving right side, boat can move backward -x, so 2 minus x. Here also you assumed x is in this direction. I cannot assume x in two directions. Boat cannot move one side and the other side simultaneously, any one side. Here my assumption is that x is the displacement given by the boat in particular direction. In which direction? I am considering in this direction. This is the direction I am assuming the boat is moving in this direction. If I am getting answer as positive, then whatever I have taken x is correct. Now my x is in this direction. X is in this direction. If I am getting positive answer, my assumption is correct. If I am getting a negative answer, my assumption here is not correct. So let's simplify this one. So what's finally coming out of this one? Let me make another colors. So here 0, so 30 into 20, you can solve it. 30 into 20 is 60, minus 30x minus 40x minus 40 minus 20x is equal to 0. Correct? 30 into 2, 60, minus 30x minus 40x minus 40 minus 20x. So 60 minus 40, 20, 30, 40, 70, 90 is equal to 90x, and x will be equal to 2 by 9 meter is the right answer for this question. Hope this is clear. Raju Manoj problem, boat problem. Okay, fine. So boat problem is over. So this kind of questions you can expect Neet, or if you are writing engineering or any other entrance examinations, you can expect this is a very common entrance based question. Okay, fine. So let's move to another question. Two masses attract each other due to normal gravitational pull. Due to normal gravitational pull. Okay, normal natural pull. You are not doing any external force. You are not moving one ball. You are not moving another body. Nothing. It's just moving. Okay. What is the mass of second body? Mass of second body. We have two masses will be there. First mass and second masses will be here. So let's consider the first mass is 1 kilogram and this is moving with the velocity v, and second mass is m and this is moving with the velocity of 2v. This v and 2v, we are not giving a v velocity and we are not giving any u velocity, any v velocity or 2v velocity. This speed is actually due to their natural gravitational attractive force. That's what the question. It's a normal gravitational force. So this means the system is at rest initially. At rest initially. So we can say we are not applying any external force. Acceleration of the system is equal to 0. ACOM is equal to 0. Initial, based on the initial conditions, and it's moving. And based on the initial conditions, VCOM is equal to 0. If system is not rest initially, if it is not given, means velocity is a constant value, but F net is 0. There is no external force. There is no external force is not applying. No external force means no acceleration. Then velocity have two values, whether VCOM is 0, whether VCOM is a constant value. What will happen will be here. As the system is rest initially, because of the statement VCOM is 0. Else VCOM will have a constant value. When VCOM will be equal to 0 means I am writing 0 equal to m1 v1 plus m2 v2 divided by m1 plus m2. I just applied the formula. Mass of the first body 1 kilogram, its velocity is v, and the second body m2, അതിൻ്റെ mass m, it's moving in opposite direction, so minus 2v. അതുകൊണ്ടാണ് velocity is a vector quantity. ഇത് plus v ആകുമ്പോൾ അത് minus v. Total mass m plus 1 is equal to 0. We'll simplify the rest of the things, and here v minus 2mv is equal to 0. V is equal to 2mv. V get cancels. M equal to 1 by 2 kilogram. M equal to 1 by 2 kilogram. Remember this concept as well. Okay, fine. Next we are going to learn the center of mass for a continuous bodies. Center of mass for a continuous bodies, the next topic. Okay, these are the various subtopic under the center of mass. Center of mass is a big heading actually. So under this one, these are the small subheadings. These are actually various model of questions which you can see in various question papers, and it may come. Okay. So write down the heading, center of mass of continuous bodies. Continuous bodies. Continuous ആയിട്ടുള്ള bodies in the center of mass. To find that we have a formula, integral x dm divided by integral dm. This is the formula to find out the center of mass of a continuous body. Okay, you don't want to do the derivation for this one, but normally this is the earlier formula. It is like a discrete system. അതാണ് m1 r1 plus m2 r2 plus m3 r3. അതല്ല m1 സെപ്പറേറ്റ് ആണ്, m2 സെപ്പറേറ്റ് ആണ്, m3 സെപ്പറേറ്റ് ആണ്. അങ്ങനെ സെപ്പറേറ്റ് ആയിട്ട് if we can able to count it 1 2 3, we can count it, then it is called a discrete system in physics, where we will use the mathematical operation of summation. Sometimes we cannot able to count it. For example, if you take a brick, and if I am asking how many number of particles are there, you will say, definitely will say infinite number, or you cannot count it. In such cases, if you cannot count the number of particles, you have to use this formula. This is similar to, you see, x dm. This is similar to m1 x1 plus m2 x2 plus m3 x3 divided by sum of the masses. Okay, in previous cases we have the sigma formula, but now because of a continuous body example on a rod, sphere, cylinder, so all these are the continuous body, where if I am asking you how many number of particles are there, you cannot say a particular number. That's what we are using the integration in such cases. If you can able to count it, suppose if you have 10 1 rupee coin, now I am asking, hey, how many rupees are with you? You will count 1 2 3 4 5 6 7 8 9 10. You will say 10 count, so 10 rupees will be there, you will say. So it is possible for a human being to count it. Then it is called discrete system. There we will use mathematical operation of addition or summation. In case if you are not able to count certain things, we will use integration method. This is a fundamental principle from the what can I say, from the mathematics. So for every body, if you are taking a rod, if you are taking a sphere, a cube, a cuboid, a triangle, lamina, all this will have a different formula for the center of mass. So that is a derivation part, and the derivation part which is not required for the entrance examination. So I am going to create over here a table, and I am writing certain value which is required for your examinations. You have to remember the value of the center of mass of various objects. So write down the heading, center of mass of various objects. Same way we will learn one set of formula for moment of inertia in the later topic. First one, so we are going to learn for a different objects. For example, the first one is a rod. Okay, so we'll draw a line, a rod of length L. Then the center of mass equal to L by 2 distance. Then the center of mass is located. So different body will have a different center of mass criteria. Okay, next one is semicircular ring. Okay, semicircular ring. No way this you have to learn it. It is a ring, okay, having a radius is equal to r. This semicircular ring in the center of mass, okay, center of mass is located over here, and this center of mass point, and the center of mass will be here, and it is 2r by pi. 2r by pi and the value r is the radius, 2r divided by pi. This is in case of a semicircular ring. Okay, next one is we have a semicircular disc. The third one is semicircular disc. Semicircular disc. So discum ringum ulla difference you know, right? So a disc. So disc is a kind of a two-dimensional structure. It is filled. A ring in it is just a wire only, one piece of wire. So in the radius it's given as r. So in the center of mass is located over here, and this center of mass equal to 4r by 3 pi. These values you have to remember. 4r by 3 pi. Diagram banam. Along with the diagram you have to write the equation also. Okay. Okay. Next one, annular ring. Annular ring. This is very important. We cannot say, but very toughest questions. So you have to remember this. So the first one is R1, first body. Sorry, R2. Bigger radius is R2, and smaller radius is R1. So two ring ആണ്. ഒരു annular ring ആണ്. So annular ring we have two things will be here. Then a formula, it is very similar to this one. 4 by 3 pi common. Then we have R2 cube minus R1 cube divided by R2 square minus R1 square. So please remember this one. It's hard to remember, I know, but yeah, we have to remember. No other way for this one. Okay, next one is called triangular lamina. Next one is called triangular lamina. The fifth one, triangular lamina. Normally how I remember, this is simple. From this one I will remember this, from this one I will remember this. Okay, so these three one shot we can remember, right? Triangular lamina. The triangular lamina is the height h. So this normally this is the center of mass. So center of mass equal to h by 3. So it's important to know. Now I am going to rub the first few things which you already know. Okay. Next one, center of mass of a hollow hemisphere. The fifth one. The sixth one. Center of mass of a hollow hemisphere. Center of mass of a hollow hemisphere. Sixth one. Center of mass of a hollow hemisphere. Hollow hemisphere and the center of mass we are going to find out. Hollow hemisphere. Hollow hemisphere means like this. Inside it is empty. So in the center of mass is radius r. This is the center of mass. Center of mass equal to r by 2. It's very hard to remember many of this formula. Hard to remember in the sense now you can remember, but maybe after 1 or 2 months you will forget about it. So yeah, take care. So sixth one. And the seventh one, I am going over here. I think you have written this side, right? So I will go from here. Okay, fine. Seventh one, hollow, not hollow, the solid hemisphere. Solid hemisphere. Solid hemisphere. Solid hemisphere difference na, inside it is filled. Radius is r and here, and this is the center of mass, and which is equal to 3r/8. And the last one which we are going to learn about is a solid cone. Solid cone. Okay, like this. Solid cone. So then the height h on center of mass is located over here, and this is equal to h/4 from bottom height on, and it is totally h/4. Okay. Hope you understand these concepts very clearly so far from the center of mass area. Okay, good. Fine. So all this formula, whatever we have written for a center of mass for a different objects, definitely you have to write it on your formula book, and you have to learn the things, then only it's important. Okay, different places we will use then and there. We will see once we are doing certain question, especially from the next area. We will see that. Okay, so far it is clear to you. So let's move to the next topic, and this is the final topic from the chapter. From the chapter like rotational motion, first topic on center of mass. It's a big topic, and this is the last session from the topic of center of mass. Okay, so you can write down the heading: center of mass of remaining bodies. Center of mass of remaining bodies. Center of mass of remaining bodies. Center of mass of a remaining bodies. This means that what? This we will learn the more or less the same concept in the chapter. I mean, in the topic of moment of inertia also. Suppose you have a big sphere, a solid sphere will be there. If I'm asking you, where is the center of mass located? You will say, hey sir, center of mass will be definitely located at the middle or at the center point of the sphere. So this point you will clearly say. But if I'm cut and removed a certain portion of the sphere, then where will be the new center of mass point? Definitely it is not at the center. Wherever the highest weight, the center of mass point will be get located. So this is a concept behind this one. Okay, so let's start with a question, and based on the questions we will try to answer it. First let's move to the concepts, then we'll go to the concept derived problem. So first one, we have a sphere. Suppose we are assuming a solid sphere, and we have removed a part of the solid sphere like this one, like this. Okay, so this is equal to a structure similar to like this, right? Okay, so we want to find out the center of mass of this area. So this much is the portion in which we have removed out. So what we can do means, we'll find the center of mass of the full sphere minus center of mass of the small sphere. So if you do this subtractions method, we will get the center of mass of the remaining portion. This is a logic will be here. So yeah, we have the center of mass general formula. If it is in x coordinate system, then we know x c o m, y ama y a, z ama z. But x la edumbodu x1. So m1 x1. M1 is the first body. So let me assume this is m1 and m2. Idinte center of mass locate in the point on x1 y1. ഇതിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് ലൊക്കേറ്റ് ചെയ്യുന്ന പോയിന്റ് ആണ് x2 y2. ഈ കട്ട് ഔട്ട് ചെയ്ത് റിമൂവ് ചെയ്യുന്ന പോർഷൻ്റെ സെൻറ്റർ ഓഫ് മാസ്. സോ ഈ സ്മാൾ സ്ഫിയറിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് ഇങ്ങനെ വരും. സോ ഈ ബിഗ് സ്ഫിയറിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് വിൽ ബി ലൊക്കേറ്റഡ് സംവെയർ ഹിയർ ആൾസോ. സോ m1 x1, the bigger sphere. Suppose this is on x axis, Appo x coordinate sum formula is like this one. Same formula is applicable for y coordinate also. You know, like ycom equal to m1 y1, like that. So m1 x1 minus, we have to subtract, this is a key point will be here, all others will be the same, m1 minus of m2. We have to do this one. This is the formula to find out the center of mass of the remaining portion. No other difference. Only thing, both numerator and denominator, a subtractions will come. Okay, this is the idea behind this one. So we will solve one question based on the concepts. Okay, we'll solve a couple of questions. One very simple one and one with a little complicated one. Okay, so we'll go around. Fine. So question is, find the center of mass of remaining portion. Center of mass of remaining portion. Find the center of mass of the remaining portion. Let's have a sphere and we have removed this much portions, and this is the radius. Find the center of mass of the remaining portion of this sphere, having radius capital R. Okay. Before going to do the questions, this is the only question which is given to us and no mass is not given, unfortunately. So what we will do, we know this is located on x-axis. So what we'll do, we know the formula. X center of mass will be equal to m1 x1 minus m2 x2 whole divided by m1 minus m2. We know, but mass is not given. If mass is not given, we know one parameter is called sigma. Okay, sigma is called what? Sigma is equal to mass per area. Sigma is called the mass per area, mass divided by area. Sigma is a material property. Sigma. Okay. Sigma we are studying in electrostatics. They are also called, it's called surface charge density. That sigma. Here it is not surface charge density. Here sigma is equal to mass per area. In electrostatics also we have learned one term called linear charge density, right? Charge by length. There we call surface charge density, charge per area. Surface charge density. So it is related to charge. Here it is related to mass. So I can say surface mass density. So this is related to mass, this is related to charge. So sigma can be related to any parameter, but if it is charge means charge per area, mass means mass per area. But it is a material property. When material will be changes, only sigma value will get changes. So m is replaced with the sigma. So both are same material. Remaining portion, that is remove in the portion, already the full portion same material. So this can be written as sigma times of A1. Area will be changes. So this the small area is the bigger area into x1 minus sigma A2 x2 whole divided by sigma of A1 minus sigma of A2. All sigmas will get cancels. We'll get the formula A1 x1 minus A2 x2 whole divided by A1 minus of A2. So this is the very common formula which we will use whenever the mass is not given. So this is important. When mass given, this is really important. When mass is not given, we will use this formula. So this is a concept in which we are also going to apply over, will be here. Okay. So let's see. So we'll going to answer the question. Okay, we want to find out the center of mass of the remaining portions over here. So let it have like this. So how many spheres will be here? We have two spheres will be here. One is the removed portion and another one is the original portion. So what is called A1? A1 is the bigger sphere area. So let's make it like this one. Bigger sphere minus smaller sphere is equal to, we'll get the remaining portion. So this sphere in the area on A1, this in the area on A2. Here area will be equal to area of this സർക്കിൾ അല്ലെങ്കിൽ ഈ ഒരു പ്ലേറ്റ് ഇതൊരു ഡിസ്ക് മാതിരി യു ക്യാൻ കൺസിഡർ. ഓക്കെ, അപ്പം ഇതിൻ്റെ ഏരിയ ഐ മീൻ ദിസ് ഈസ് നോട്ട് ലൈക്ക് എ സിംഗിൾ വൺ. സോ ഇതൊരു ഡിസ്ക് ആണ്. യു ക്യാൻ കൺസിഡർ ലൈക്ക് സ്ഫിയറിൻസ് ഉള്ളത് കോൺസെപ്റ്റ് വേറെയാണ്. സോ ഇറ്റ്സ് എ ഡിസ്ക്. അപ്പോൾ ഡിസ്കിൻ്റെ ഒരു പോർഷൻ യു ക്യാൻ കൺസിഡർ ലൈക്ക് നോർമലി നമ്മൾ എടുക്കുന്ന പ്ലേറ്റ്, ആ പ്ലേറ്റിൻ്റെ ഒരു പോർഷൻ കട്ട് ചെയ്ത് റിമൂവ് ചെയ്തു. സോ അതേമാതിരി ഇരിക്കുന്ന സ്ട്രക്ചർ. സോ ഏരിയ എന്ന് പറയുമ്പോൾ ഇതിൻ്റെ റേഡിയസ് ആണ്. സോ പൈ ആർ സ്ക്വയർ, ഡിസ്ക് ആണെന്നുകൊണ്ടാണ് പൈ ആർ സ്ക്വയർ. ഡിസ്ക് ലൈക്ക് സ്ട്രക്ചർ, ഒരു പ്ലേറ്റ്, അതാണ് ഇതിൻ്റെ ഏരിയ. വാട്ട് ഈസ് ദ ഏരിയ ഓഫ് ദിസ് വൺ? ഇതിൻ്റെ റേഡിയസ് എவ்வளோ? സ്മാൾ സ്ഫിയറിൻ്റെ റേഡിയസ് എவ்வளோ? r/2. സോ ഇറ്റ് ഇസ് ബിക്കം pi r/2 the whole square, which is equal to pi r square divided by 4. This is pi r square. So രണ്ട് ഏരിയ we got. Where is center of mass of the bigger sphere? ഇത് പോർഷൻ റിമൂവ് അല്ലാതെ ഇത് ഫുൾ ആയിട്ട് ഇരിക്കുമ്പോൾ ഇതിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് വിൽ ബി ലൊക്കേറ്റഡ് അറ്റ് 0,0. ഈ ഹാഫ് ആയിട്ട് ഇരിക്കുമ്പോൾ ഈ പോർഷൻ റിമൂവ് ചെയ്യുമ്പോൾ ഇതിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് വിൽ ബി ഹിയർ. ദാറ്റ് ഈസ് എക്സ് കോർഡിനേറ്റ് r/2, y കോർഡിനേറ്റ് 0. സോ ഇതിൻ്റെ സെൻറ്റർ ഓഫ് മാസ് പോയിന്റ്സ് ആണ് r/2, 0. Okay, now it is clear, only x coordinate is changing 0 to r/2, but y coordinate will be same. So immediately I can write ycom is equal to 0, no doubt. Definitely it is on the x-axis. Now if it is a full sphere, the center of mass is located at the point 0,0. Now I removed a portion, so here it is empty. So definitely the center of mass from here it will locate to left side, highest weight ulla side ku locate. So we'll find XCOM. So XCOM is equal to area we know, it is pi r square. X1 is 0 minus second area pi r square by 4. X2 is r/2 divided by areas minus A1 minus A2. So pi r square minus pi r square by 4. So throughout the journey here this is cancel, pi r square cancel, pi r square cancel, pi r square cancels. So in the numerator we have minus r/8 will be there. Denominator 1 minus 1/4. So minus r/8, 1 minus 1/4 na 3/4. So this will get cancels, right? Either 8 ആണ്. So this will get cancelled. Balance 2 ഉണ്ടായിരിക്കും. So 2 will come. So minus r/6. Minus indicate what? It is shifting. ഇത് this we have considered like an original position. Origin ആയിട്ട് consider ചെയ്തു. ഇവിടുന്ന് this will be shifting because it is negative side. Negative means minus x-axis ലോട്ട് shift ചെയ്യും. How much distance it should shift? r/6. So the new center of mass position will be r/6 towards left. r/6 towards left. Very important question. Very important question. You can expect this model of question for the entrance examination. Very important. Very, very important. Okay. So this is clear. Okay. So r/6. Sometimes in questions they will say whenever we have removed a certain portion of the masses over will be here, the center of mass will be shifted by alpha times r. The value of alpha, we know how much it is shifted, minus r/6. In this case, what is the value of alpha? Alpha is equal to minus 1/6. Minus indicate left side. So magnitude wise alpha and value 1/6 ആണ്. Negative indicate it is shifting towards left. Very important. Okay, so we are going to do the next problem. Fine. Okay. Write the question. Find the center of mass of the remaining portion. Remaining portion means what? The shaded area. Shaded area, to make it clear. Okay. So this is a kind of a rectangle whose length is 2r. And breadth is r. We cut and remove a disc. ഇതൊരു പ്ലേറ്റ് ആണ്. ആ പ്ലേറ്റിൽ നിന്ന് ഒരു സെമി സർക്കുലാർ ഡിസ്ക് റിമൂവ് ചെയ്തു. Once we removed the semicircular disc, what will happen to the center of mass of this one? So this is a question which is given to us. Okay, so from this one we know to find out the remaining portion, we have a full rectangle minus we have to subtract a disk, so that we'll get our structures like this one, right? Okay, so to solve this problem you have to consider an origin point. So origin, I mean you have to consider the center of mass of the two bodies. Where is the center of mass? Okay, so where is the center of mass of this first body will come? This is exactly the full rectangle. Center of mass will be coming at the will be here. Correct? Exactly. In the central varum. Suppose if you have you can assume like x coordinates, y coordinates, you can assume anywhere. I am assuming this is the center area. I am assuming this is the center area. I assumed an axis like this one. Then for this one I have giving a coordinate. I am assuming this is the center area. I am giving these coordinates as 0, 0, 0, and this distance, this I don't know whether it is r by 2 or r by 3, but that value I don't know. So the point is like you want to know where is the center of mass of a center. Okay, so let's make sin another. Okay, if you have considered, for example, if you have considered your x-axis, and if you have considered this as the origin 0, 0, if you consider this as the origin, so that will be easier, right, for you. So if you consider in case of a sphere, in case of a previous problem, we have considered this is this origin point 0, 0, we assumed like this one. Now we have taken this is the original point 0, 0. So we know for the full sphere, you can consider this x and y axis anywhere. Now here I consider, so where is the center of mass point will be located, or will be here. You should have an x coordinates and you should have a y coordinate. So what is your x coordinate? Half of this one, r by 2, and your y coordinate is r. You have to consider like this one. Okay, so this is the point in which you are getting for your x coordinates and your y coordinates. So I am writing here it as r by 2 comma r. This is one way. And another one is, you know the center of mass of a disk. Disk in the radius r ayirundana, the same diagram is drawing like this. Disk in the radius r ayirundana, where is the center of mass point is located from the bottom. We already written, right, center of mass of a continuous body, it is called 4r by 3 pi. 4r by 3 pi for a disk, we already written for. So this 4r by 3 pi from here means from here. So from here is how much? So here one center of mass is located, which is 4r by 3 pi. But the y distance we know it is r by 2. But x distance is not 4r by 3 pi. So you know the complete distance from here to here is how much? 0 to r. Adin idu minus cheyyanam. So the complete distance is r. So you want to get this distance. You want to get this distance, because all distance we are taking from the origin. Once you want to get this distance, the distance from other end is given 4r by 3 pi. Then 4r by 3 pi is distance. Total distance is how much? R. So r minus 4r by 3 pi, what you will get? You will get this piece. That means the distance from the origin. That is the x coordinate. So this x1 comma y1 is given. In x2, the full length minus this subtract. So r minus 4r by 3 pi. Small letter use 4r by 3 pi. The small letter. So 4r by 3 pi. Small letter. So 4r by 3 pi. This is the x2. What is the y2? Y2 will come exactly at the center. That is the y2 coordinate. Y2 coordinate is equal to r by 2. Okay. So, this is the x1, y1 we got. This is the x2, y2 also we got. R minus 4r by 3 pi. Very important. You have considered this as the origin. This problem comparable to previous problem, little complicated. This is the origin. From the origin, if full rectangle in the center of mass. So, r by 2, x r by 2, y r exactly. x r by 2, y r distance exactly at the center. But a disk anengil, we already know the center of mass of a disk from the bottom point. Bottom point is 4r by 3 pi. But we actually need to get this distance. In order to get this distance means full length minus red minus. Red minus you will get this distance. This is what we did. R minus 4r by 3 pi. Y2 is equal to r by 2. And you know area of this one. What is the area of this one? Length into breadth. So 2r square is the area. What is the area of this one? A2. A2 is how much? With full disk pi r square. Half the disk pi r square by 2 is the area. R small letter. So pi r square by 2. So we got all the things. We can find XCOM. XCOM equal to a1 x1 minus a2 x2 whole divided by a1 minus a2. A1 value is given to you 2r square. A2 value is given to you pi r square by 2. x1 is given r by 2. x2 is given r minus 4r by 3 pi. This is simplified. Similarly, we can go and find out YCOM a1 y1 minus a2 y2 whole divided by a1 minus a2. So you can find x coordinates and y coordinates accordingly. Okay. So sometimes, so this is the idea, you can substitute, you will get the answer. In some cases, students will do in another way. Another way means maybe some people with some other idea can also do in a different way. What is that method is like? Okay. People will consider. So in this diagram, now here we have considered the origin. Instead of considering the origin in such a way that people will consider origin is exactly at the center. This is my origin considerable. So 0, 0. So it's very clear x1 and y1 is 0, 0. x1, y1 will be equal to 0, 0. So this is clear. Area A1, A2 have no changes. That is already what we have seen in the previous step, same thing. But so now we know this distance is what called r. So as the disk in how much area we have removed? 4r by 3 pi we have removed. So we need to get this much distance over will be here. That is our x2. So our x2 will be equal to r. In the total radius r ana. Total radius is given as r, right? So this is r by 2. Total radius is given as, so this is r by 2 minus 4r by 3 pi. Previously, I think just before, previously with the red color pen, I have written r minus 4r by 3. It's not r minus, please correct it. It is r by 2 minus because half the distance. Okay, in the previous case and this case, in this current case, it is r by 2 minus 4r by 3 pi. Previously, I have written with the red color. There it is given as r minus 4r by 3. Why? Because we have taken this as the origin. Now origin will be changes. Origin will be here. So r by 2 minus 4r by 3 pi will come. And your y2 coordinate is what? Y2 coordinates. So here we have, and y2 coordinate is given as 0 because your center of mass kanam ee oru point il aayirikkum idana idinte height. So this will be considered as the origin. From origin for the rectangle x1 and y1 is 0, and for the origin with respect if origin is considered will be here x2 is r by 2 minus e 4r by 3 pi. So this much portions we will subtract. This red color portion subtract origin distance we got x2, and y2 is, it's again 0 because definitely we know this 4r by 3 pi is located over will be here. So the coordinates will be x2 comma y2. Okay, x2 is this one, but y2 on the x-axis is equal to 0. This also you can substitute and you can find the answer. So all answers will be the same, but the only difference is where you are considering your origin. So while you are getting the question, if it is a sphere, immediately consider the center and solve it and find the answer. But if it is a kind of a rectangle kind of thing, I say comparable to considering origin over here, it's better to consider origin over here will be the best way to answer this question. Okay, you can try this as well. So I think the center of mass topic is over. We have learned many concepts, but important, there is a chance to get question out of this one. Okay, So thanks for watching the first topic and the first topic of this rotational motion series video. Thanks.